Hello everyone, welcome. So today we're going to be designing a light detection alarm system, as you can see. So the photoresistor, which I'll get into later, detects light and that turns on the LED. And when it's dark and I close the curtains, the LED turns off. So there is a slight delay, which I'll get into later, and I can improve on this with my code, which I'll explain later, but let's get started. So this is our circuit diagram of our system, and so we have our photoresistor. So a photoresistor is a light sensor, essentially. So when it detects light, the resistance actually drops. So since the resistance drops, our LED is going to turn on. So our LED has like a alarm effect, if you can tell, because it kind of detects light in our system, right? So once the resistance drops, the LED turns on, and that's when you detect the light. But when the photoresistor doesn't detect the light, the resistance actually increases. So because it increases, the LED is no more on again, and that is how our system is going to look like. So if our photoresistance reading surpasses a limit, then the LED doesn't turn on. If it's below that limit, and if the resistance is low, and if it does detect the light, the LED turns on, and that is our light detection system. So we're going to be connecting our photoresistor to a analog input pin voltage, and I'm going to be using the A0 input pin, and our LED is going to be connected to a digital output pin 8. So this is our breadboard. Once again, we're going to be connecting our photoresistor to our breadboard. So I use these two pins, and that's our amazing, beautiful photoresistor connected to the board. Then I'm going to connect our 10 kOhm resistor to our photoresistor. This is to limit the current, remember, because we always need that resistance. So I'm going to connect that. I'm going to use the ground wire to connect the end of that resistor to ground. The blue power line is our ground. Then I'm going to be connecting the red wire to the voltage side of things. So the red power line is going to be our 5-volt voltage, right? So I'm going to be connecting the other end of the photoresistor to our 5-volt voltage. Then I'm going to be connecting the green wire that's going to be connected to our analog reading pin. So that's going to be our analog voltage input pin. So I'm going to connect our other end of the photoresistor to that wire. Then I'm going to add another resistor, an LED. This is our separate system of our circuit, so we always need that current limiting resistor, remember? So that's going to be our 220 ohm resistor. And I'm going to connect another wire to the other end of the resistor that's going to be connected to our digital output pin. Now we're going to be connecting it to our board, and so I'm going to be connecting all the wires to our Arduino board, and so I'm going to connect our LED output wire to the digital output pin 8. I'm going to connect our photoresistor wire that's going to be connected to the analog input voltage pins. That's going to be our A1 voltage analog voltage pins. I'm going to connect our voltage power line to the 5-volt pin, and then I'm going to connect our ground wires to the ground power pin, as you can see on the board. So this is how our system turns out to be. And now we're going to be testing. So this is our code. I set the LED pin to our output, the photoresistor pin to our input, and then I have our threshold. My threshold value is very high, but I set it to low if it surpasses it, set it to high else, and then I delayed it by 400 milliseconds. This is how our system looks like. The LED is on, and so yeah, thanks for watching.